Let's talk about something that's all around us all the time, but we barely ever think about it. I'm talking about the air we breathe, the water we drink, even the ground under our feet. So, what exactly are natural resources? Let's get into it. All right, to kick things off, just do me a favor. Wherever you are right now, just look around. Go on. What do you see? Okay, now let's focus on the really, really basic stuff.
Okay, first up, think about the air you're breathing, like right now, in this exact moment.
And then there's the water. The stuff that literally keeps you going. And of course, the food you eat. Every single bite of it starts somewhere. And that somewhere is the soil. So you've got air, water, and soil. Pretty simple, right? We literally can't live without them. But have you ever really stopped and thought, where does all this stuff come from? Well, the answer is actually pretty simple. It's not like this stuff is made in some factory, right? Nobody invented it. It's all just here. It's a gift from the earth. It comes from nature. Okay, to really get this, let's break down that word resource. It sounds a little formal, but it's super simple. A resource is just anything that's useful to us. Seriously, anything. A pencil? That's a resource for writing. Your phone? A resource for, well, a million things. If you can use it to do something, boom, it's a resource. So when we talk about resources, they basically fall into two big buckets. On one side, you've got the human-made stuff. Things we build and create, like buildings, cars, all that tech in our pockets. But on the other side, you have natural resources. These are the things that were already here on our planet, just waiting for us. Okay, so let's put those two ideas together. What do we get? Our main definition for today. A natural resource is anything, and I mean anything, that's found in nature and can be used by living things. The key thing to remember is this. We don't make it, we just find it, and then we use it.
And wow, this covers a ton of stuff. We're talking about things that are alive, like forests, animals, and plants. It also includes all the materials we dig up from the ground, like different minerals or fossil fuels. And it even covers the really huge, powerful things, like the energy we get from the sun, the oceans, and yup, even the very ground we're all standing on.
But okay, why is this so important? Who cares about the definition? Well, here's why it matters. We're not just talking about things that are nice to have. We're talking about things that we absolutely 100% need to survive. Think about it like this. It's pretty straightforward, right? Step one, without air, we can't breathe. That's a big one. Step two, without water, well, we can't live. And step three, without soil, we can't grow our food. You take away any one of those things, and everything just stops. Life as we know it just wouldn't be possible. So really, it all boils down to this one huge idea. Natural resources support all life on Earth. I'm not just talking about people. I mean everything from the tiniest bug to a massive whale. And, yep, us too. So next time you're outside, just take a second, look around, and ask yourself, what part of nature is helping me live right here, right now? All right, welcome everyone. So, have you ever really thought about what our planet gives us for free? I'm not talking about the big, obvious stuff like oceans and mountains. I mean the actual stuff that makes everything else possible. Well, today we're pulling back the curtain and taking a look at Earth's natural resources. This is going to be like a user's guide to our own planet. Let's get into it. So, to get started, let's talk about something I know you've seen a million times in movies, in your favorite shows, even in video games. We're going to see how something from science fiction is actually playing out right here, right now. Okay, picture this. You're watching a sci-fi movie, right? Maybe it's about astronauts stranded on Mars, desperate for air. Or a story set on a desert planet where water is more valuable than gold. Or even a futuristic city that's about to run out of power. The whole story, the drama, it almost always comes down to one thing: a desperate hunt for limited resources. It's what makes those stories so intense. And yeah, it's easy to think, phew, glad that's just a movie. It feels like something that happens light years away in a galaxy far, far away, right? But what if it's not? What if that same kind of pressure, that same challenge, is happening right here on Earth, every single day? And well, this is where fiction crashes into reality. That big struggle for survival, it's not just for the movies. It's a real thing here on our planet. See, if we're not smart about how we use what the Earth gives us, our natural resources, life can get really, really tough. This isn't just a storyline anymore. It's our reality. Okay, so I keep saying natural resources. It's a term we hear all the time, but what does it actually mean? Let's break it down and get a super simple definition.
Honestly, it's way simpler than it sounds. A natural resource is just useful stuff that comes directly from nature. That's it. It's not something we build in a factory. It's the things the earth just has. Like the water you drink, the air you're breathing right now, the wood from trees, even the sunlight. It's all the raw ingredients our planet gives us to work with.
All right, so there's a lot of this stuff, right? To make sense of it all, we basically sort all these resources into two big buckets. And understanding the difference between these two categories, well, it's probably the most important part of figuring out how to live on this planet wisely. So think of it like two teams. On Team Renewable, you've got the resources that can grow back or get replaced. And on Team Non-Renewable, you've got the stuff that once you use it, it's pretty much gone for good. It's a one-shot deal. Let's check out the player lineup for each team. First up, Team Renewable. These are the comeback kids, the resources that nature can make more of. We're talking about air, which gets cleaned by plants, water, which goes through its own cycle, forests, because, we can plant more trees, and the ultimate renewable resource, sunlight. There's no running out of that anytime soon. And then you have Team Non-Renewable, the one and done crew. This is the stuff that has a limited supply. Once it's gone, it's gone. Or it takes so long to form again that we'll never see it. This is stuff like soil and rocks, minerals like iron and copper, and the big ones, fossil fuels like coal, oil, and natural gas. I mean, we're talking millions of years for that stuff to form. We can't just wait around for that. Okay, so that seems pretty straightforward, right? Use the renewable stuff, be careful with the non-renewable stuff. Easy. But it's not quite that simple. There's a twist. A pretty big one, actually.
So here's a thought experiment for you. We just put forests on Team Renewable because trees grow back. But what if we cut them down way faster than new ones can grow? I mean, really think about it. Is it still a renewable resource then? And here it is, the plot twist. A renewable resource can become non-renewable. It all depends on us, our actions. If we use something, like a forest, or even the fish in the ocean, faster than nature can replace it, then for all practical purposes, it might as well be non-renewable. That line between the two teams, it can get really blurry, and it's our choices that blur it. And that right there, that's the whole point. This isn't just about learning some science terms. It's about realizing that we are a huge part of this story. It's our planet, and it's our choices that matter. So let's do a super quick rundown of what we figured out. 1. A resource is just useful stuff. 2. Natural resources come from, nature. 3. There are two big teams, renewable and non-renewable. And the big one, 4, our actions can basically make a resource switch teams. That's huge. This brings us right back to the beginning, back to those sci-fi movies. Our survival really does depend on how wisely we use our resources. It's the same exact story, just without the cool spaceships. The real key isn't just about using this stuff, it's about being smart about how we use it. And listen, this is why this matters to you. Right now, this isn't some boring chapter in a textbook. It's happening all around you. Every time you turn on a light, take a drink of water, or even just look at the phone or computer you're watching this on, you're a character in this story. It's all connected. So, as we finish up, I'm going to leave you with a challenge. Just one question to chew on. Now that you know all this, what is one resource you're going to use a little more wisely today? It doesn't have to be massive, but a small choice can make a huge difference. Think about it. Thanks for hanging out with me today.
Have you ever just stopped and thought about what's keeping you alive? Right this very second. It's something that's all around us, and it's even inside of us. Today, we're going to talk all about it. Air. All right, so wherever you are right now, I want you to try something with me. Go ahead and close your eyes if you'd like. Now, take a really nice, deep breath in. And then, just slowly let it all out.
Yeah, it kind of feels like nothing, right? It's totally invisible. But have you ever really truly stopped to wonder, what is that stuff you just breathed in? What's it made of?
Well, guess what? That's exactly what we're here to figure out. So let's start with the basics, the air you breathe. It's a little weird to think about, isn't it?
I mean, you can't see it, you can't really hold it in your hands, but air is, without a doubt, one of the most important natural resources on our entire planet. Seriously, without it, none of the life you see around you, none of it would exist.
So, where does all this air actually live? Well, it kind of forms this huge invisible blanket that wraps all the way around the Earth. And this big protective blanket, it actually has a name you've probably heard in science class: the atmosphere. You can think of it like a giant invisible shield made up of all these different gases, and it's wrapped around our planet to keep everything, well, just right. And let's be super clear about this. Without that blanket of air, life on Earth just wouldn't be possible. Not for people, not for animals, not even for plants. It is that important.
Okay, so what is this invisible stuff actually made of? If we were to look at the recipe for air, what would the ingredients be? It's kind of like baking a cake, but for an entire planet.
So the very first thing you need to know is that air isn't just one thing. It's actually a mix, a blend of a bunch of different gases all swirled together.
So let's take a look at the main ingredients here. The biggest chunk, see that? The 78%? That is a gas called nitrogen. Now, the next biggest piece, at 21%, is oxygen. And that's the part we really need to breathe. So what about that tiny little 1% sliver left over? Well, that's pretty much everything else.
Okay, so thinking about that chart, quick pop quiz. Which gas makes up the biggest part of the air we're all breathing right now? Give you a second to think. If you said nitrogen, you are absolutely correct. It is the #1 ingredient.
All right, so let's zoom in on those two main ingredients from our recipe, nitrogen and oxygen. What do they actually do for us and for the planet?
Let's start with the big one, nitrogen. It's kind of like a ghost gas. You can't see it and you can't smell it. And here's something interesting. It doesn't help things burn, it actually puts fires out. But even though we don't use it when we breathe, it's absolutely essential for life. Plants need nitrogen to grow big and strong, which is exactly why it's a key ingredient in the fertilizers that help grow our food.
And now for the gas you've all been waiting for, oxygen. This is the superstar. This is the gas that literally fuels our bodies and all animal life. It's what allows a campfire to burn, and it's what our bodies use to create energy from our food. It's so crucial that even fish have figured out a way to breathe it by pulling tiny bits of it right out of the water.
Just think for a second about how much we depend on it. Take a look at this number, 22,000. That is about how many times you breathe every single day. 22,000 times. Your body just automatically reaches for that oxygen in the air to keep you going. Isn't that amazing when you think about it?
Okay, so as we get ready to wrap this up, let's take one final thoughtful breath and just think about what we've discovered.
So we've learned that air isn't just empty space, right? It's this very specific recipe of gases, and oxygen is the key ingredient that allows us to live. But doesn't that leave us with a bit of a mystery? If oxygen is the stuff we need for breathing, why is there so much nitrogen? I mean, almost 80%. What is all that other gas doing? That is a really good question to think about. Until next time.
We're surrounded by it every single moment of every single day. But we almost never think about it. Today, we're going to take a closer look at that invisible, life-giving stuff all around us, the air we breathe. To get started, let's just do something really simple together. Go on, take a deep breath in. And now slowly let it all out. Have you ever really stopped to wonder what was in that breath you just took? It's pretty easy to forget about air, right? I mean, you can't see it. It looks like there's nothing there at all. But that invisible nothing is actually one of the most important resources on our entire planet. So, if it's that important, we should probably know what it is. Let's try and put a definition to this invisible stuff that keeps us all going. Okay, so here's the key. Air isn't just one thing. It's actually a mix, a recipe of lots of different gases. And all those gases together wrap around our planet in a surprisingly thin layer called the atmosphere. Think of it like a protective bubble that makes all life on Earth possible. So if air is a mix of gases, what's in it? What's the secret recipe? What are the actual ingredients you're breathing in this very second? Let's find out. The recipe for the air we breathe is actually pretty simple. The biggest ingredient by far is a gas called nitrogen. It makes up 78% of the air. Wow. Then, most of what's left, 21%, is oxygen.
And everything else? All the other gases are crammed into that tiny 1% slice. It's not a lot, but some really important gases are in there, like carbon dioxide, which plants need to survive. And what's really amazing is that this recipe, it stays pretty much the same all the time.
Okay, so let's do a quick check. Think back to that chart. Of all the gases floating around us, which one makes up the biggest part of our air? All right, let's zoom in on the two main players in that recipe. You could call them the superstars of our atmosphere, nitrogen and oxygen. So if you guessed nitrogen, you are absolutely right. It is, by a long shot, the most common gas, making up that huge 78% of the air. So what's the deal with nitrogen? Well, you can't see it, and you can't smell it. It also won't help a fire burn, but it's super important for life. You see, plants need it to make proteins, and that's why we use nitrogen in fertilizers, to help all our food and crops grow nice and strong. And now for our other superstar gas, this is the one we usually think of when we talk about breathing: oxygen. Even though it's only about 21% of the air, this is the part that is absolutely 100% essential for us and for all animal life. Just take a look at this number for a second. 22,000. That's about how many times you breathe every single day. And every one of those breaths is your body pulling in the oxygen it needs to survive. It's incredible, really. So we know oxygen is a huge deal for us, but it does more than just let us breathe. Oxygen also supports combustion, which is just a fancy way of saying fire needs oxygen to burn. And it's not just for those of us on land. Animals that live in the water, like fish, get the oxygen they need because it's dissolved right there in the water with them. So you see, the air around us isn't just empty space. It's a very specific, life-sustaining recipe. Hopefully, that gives you something new to think about the next time you take a nice, deep breath. But all of this leaves us with one huge question. With billions of people and animals all breathing thousands of times a day, constantly using up oxygen, why doesn't it ever run out? How does nature keep this whole recipe in perfect balance? Well, maybe that's a story for another time.
Hey there! Today we're going to talk about something we all use every single day: water. We usually don't even think about it, right? Well, we're going to explore why thinking about it and saving it might just be one of the most important things we can do.
You know, when you see pictures of Earth from space, you see all that blue. It's called the blue planet for a reason. But looks can be a little deceiving. Let's uncover a fact that might totally change the way you see all that water. Just look at this number, 0.03%. That's it. That's the tiny, tiny amount of all the water on the entire planet that is actually fresh and available for us to use. Most of it is salt water or frozen solid in glaciers. So everything we need for living comes from that incredibly small little drop.
So, that brings up a really big question. If we have so little to start with, what happens when we aren't careful with it? What do you think happens when we waste even a little bit of that tiny amount?
Well, the answer is pretty simple, and it's also really serious. Saving water, it isn't just a nice thing to do. It's not optional. It's absolutely necessary for us to survive.
Okay, so if it's that important, we should probably get clear on what water conservation actually is. What are we really talking about when we say that?
It really comes down to two main ideas. First, using water efficiently. That just means getting the most out of every single drop and not using more than you actually need. And second, reducing waste. You know, fixing leaky faucets and not just letting good, clean water run down the drain. It's really all about being smart with our water so that it's there for us and for everyone who comes after us.
We know it's necessary, but why is the need getting bigger and more urgent all the time? Let's take a look at the pressures that are building up on our super limited water supply.
Let's break down the main reasons. First, our population is getting bigger. More people means we need more water for drinking, cooking, everything. Second, our industries are growing, and making all the stuff we use takes a massive amount of water. Third, there's farming. We need it to grow our food, but it is the biggest user of fresh water on the whole planet. And remember, all of these things need water from that same very limited supply.
So, when you see all these growing needs, all pulling from the same small source, the answer becomes really clear, doesn't it? It's a simple math problem, really. Demand is going up, but the supply is staying the same. The only thing to do is to protect what we have. Now, to finish up, I want to leave you with one last question to think about. It's a question about our future and the challenges we're all going to face together. So just think about this. If the number of people on our planet one day doubles, what do you think happens to the demand for that same tiny 0.03% of water? It's a tough thought, but it's a really important one to keep in mind. Thanks for listening.
Hey there. Today, we're going to talk about something you use every single day, probably without even giving it a second thought. And that's water. You know, when you see pictures of Earth from space, what's the first thing you notice? All that blue, right? It looks like this gorgeous blue marble, just covered in these huge, endless oceans. And yeah, that's totally true. Our world is mostly water. But here's where it gets interesting. There's a really important secret kind of hidden in all that blue. See, just because all that water is there doesn't actually mean we can use it. So that brings up a pretty big question, right? When you picture all the water on our entire planet, I mean, think about it. The oceans, the rivers, all the ice up at the North and South Poles. How much of all that water do you think is actually available for us to use? You know, for drinking, for growing our food, for everything. Just take a guess. What percentage do you think it is? Okay, here's the answer, 0.03%. Wow, that is an incredibly tiny number, isn't it? Let's just look at that for a second. What a tiny, tiny fraction. And this is really the main point to remember. See, almost all of the water on Earth is salt water in the oceans, which, we can't drink. And a whole bunch of the rest is locked up, completely frozen in glaciers and ice caps. So that super small amount that's left over, well, that's what every single person on the planet has to rely on. So when you really stop and think about how little there is and how precious that makes it kind of makes you wonder, right? If we aren't careful with this very, very small supply, what happens? What are the consequences? And this leads us to a really important idea. And that idea is water conservation. So let's talk about that. What does that phrase actually mean? Okay, so when you boil it all down, it's about two really simple but powerful ideas. First, using water efficiently. That just means using only what you really need. And second, reducing waste. Pretty simple, right? It means not letting that precious water just go down the drain. But check out the last part of that sentence, for future use. That's super important because saving water isn't just about having enough for us right now, today. It's about thinking ahead, making sure that people in the future, your kids and their kids, will also have the water they need. All right, so we know what water conservation is. Now let's dig into why it's so important. Because it's not just some nice thing to do, it's actually becoming something we absolutely have to do. And it all comes back to this one basic fact. The fresh water we can use is limited. Let's try an analogy. Imagine all the fresh water in the world could fit into just one water bottle. Just one. And every single person on Earth has to share that one bottle. You'd be super careful with every single drop, wouldn't you? Now, here's problem number one. The world's population is growing, and every new person needs a drink from that same bottle of water. So you've got more and more people all sharing the exact same amount. Okay, challenge number two is all the stuff we make and use. Just think about it for a second. Your clothes, your phone, your computer, it takes a ton of water to make pretty much everything. So as we make more stuff, we're taking more water out of that same bottle. And last but not least, food. To feed all those growing numbers of people, we have to grow more food. And farming? Well, it uses a massive amount of water. So when you add it all up, more people, more industry, more farms, they're all putting a huge amount of pressure on that same tiny 0.03%. Okay, so this brings us to one last thing to think about today. And this part isn't just about learning the facts, it's really about looking to the future. So let's just pause for a second. With everything we've just talked about, the super limited supply and all the things that need more and more of it, just take a moment and really think about what that means. And I'm going to leave you with this one last question. If the number of people sharing that one single bottle of water were to double, what do you think happens to the demand for it? And what does that mean for our future? It's definitely something for all of us to think about, and maybe to do something about. Hello and welcome. Today, we're going to talk about a source of power that's, well, it's all around us. It's something we see almost every single day.
So let's get right into our explainer on solar energy. Think about it. No matter where you are in the world, this is something you can always count on every single day, without fail. The sun rises. But have you ever really stopped and thought about that? All that light and all that warmth, that's a huge, huge amount of energy. And it's all being sent across millions of miles of space, right to us. And you know, that energy isn't just some small bonus. No, it's the main engine. It's really the #1 source of power for pretty much everything that lives and happens here on Earth. Okay, so to really get this, let's zoom out and start with the big picture. First off, what even is solar energy and where does it all come from? Well, like the name suggests, solar energy is simply the energy we get from the sun. It travels all the way here, and it arrives as both light and heat. It's that warmth you feel on your skin on a sunny day, and it's the daylight that makes our world bright. Okay, now here's something that's really cool about this. Solar energy is what we call a renewable resource. So what does that actually mean? Well, it just means we can't use it up. The sun is going to keep on shining. It's going to send us more energy tomorrow, and the day after that. It literally renews itself. Every single day. Right, so we know the sun sends us energy, but what does that energy actually do, for the planet itself? Let's take a look at its global impact, because it really is like Earth's own natural engine. For example, just think about rain. Where does rain come from? Well, it all starts with the sun. See, the sun's heat, it warms up the water in our oceans and lakes, and that makes the water turn into vapor. We call that evaporation. Then, that vapor rises up, it gets cooler, and it forms clouds. And, you guessed it, eventually those clouds give us rain. The sun is what drives that whole entire cycle. And it's not just the water cycle. The sun's power doesn't stop there. The way it heats our planet unevenly, well, that's what creates wind. And maybe the most amazing thing of all, plants. Plants use sunlight to make their own food. That's a process called photosynthesis. And that one thing is the foundation for almost all life on our planet. Pretty incredible, right? So let's just pause for a second and think about that. If we didn't have the sun's heat to get things started, what would happen to the water cycle? What would happen to the rain, the rivers, even the clouds? So we've seen how the Earth uses solar energy in these amazing ways. But what about people? What about us? Let's talk about the human connection now and see how we figured out how to capture and use this incredible power. The key to all of this, the very heart of the technology, is something called a solar cell. And what it does is really quite simple but amazing. It's a special device designed to take sunlight and turn it directly into electricity. You've probably seen these. Lots of solar cells are grouped together to make solar panels. You see them on rooftops, making electricity for the homes below. We can also use the sun's heat in simpler ways, like in solar cookers. And get this. Way out in space, satellites and the International Space Station, they rely completely on massive solar panels to get all the power they need. Okay, so using the sun for power sounds pretty great, right? And for the most part, it is. But, like with anything, it's important to see the whole picture. There are some really bright sides, but there are also a few clouds, or what we call limitations. Let's start with the good stuff. The biggest advantage for sure is that it's renewable. Remember, the sun isn't going anywhere. Another big one, it's non-polluting. It doesn't make any harmful smoke or gas. Plus, there is just so much of it available everywhere in the world. And every time we use solar, it means we rely a little bit less on other fuels that can harm our environment. But there are some challenges. The biggest one is pretty obvious. Sunlight isn't always there. It's not constant. A cloudy day means you get less energy. It also depends on where you are on the planet. And of course, there's no sunlight at night. Another thing is that to get a lot of electricity, you need a pretty big space for all the solar panels. This next question might sound a little obvious, but it really points to the main challenge we just talked about. So just pause for a second and think, why don't solar panels work well at night? What's the one thing that's missing that they absolutely need? So even with those challenges, the future for solar energy is looking, well, very bright. So for our last section, let's look ahead and see what's next for this amazing technology. And here's the really great news. Scientists all over the world are working hard on this. They're constantly making solar technology better and making it work more efficiently. And remember, every time we use solar power, it helps reduce pollution. That makes it a really, really important piece of the puzzle if we want to build a sustainable future for our planet.
And if you want a perfect example of how reliable this technology can be, just think back to space. So far from Earth, where there are no other choices for power, our most advanced spacecraft depend completely on solar panels. Without that sunlight, they would just be silent pieces of metal floating in space.
So, we've kind of come full circle, haven't we? We've seen that the sun is so much more than just a bright light in the sky. It's the power behind our technology, it's the power behind our weather, and our food. It truly, truly is the engine of life on Earth.
So when you think of a forest, what's the first thing that pops into your head? Is it maybe something out of a fairy tale, an enchanted, magical forest? Well, today we're going to go on a little journey. We'll leave that fantasy world behind and discover the real magic of forests. And trust me, it's even more amazing.
You know, if you think about your favorite stories, books, movies, you name it, I bet a lot of them have a forest in them. And they're always shown as these kind of mysterious, powerful places, right? Like they're hiding some ancient secrets.
Well, here's the cool part. That whole idea of a powerful forest, it's not just make-believe. Forests do have a power, a very real one, and it affects every single person on this planet. So what is it? What's their real power? Okay, so let's get into it. First up, why we need forests. And to put it simply, they are the planet's life support system. So in the real world, forests are truly in charge of life. They actually control the world all around us. It's not magic, it's science. They're constantly working kind of behind the scenes, almost like the Earth's operating system, you know? Keeping everything running smoothly and in balance.
Let's look at the gifts a healthy forest gives us. First, and this is a big one, they create the very oxygen we need to breathe. They also help control rainfall patterns, which is super important. They keep our climate stable, kind of like a thermostat for the whole planet. And finally, their roots hold all the soil in place so it doesn't just wash away.
So, that makes you wonder, doesn't it? What would actually happen if our forests just disappeared?
Well, it wouldn't be good. A world without forests, it's a pretty scary thought. Our oxygen levels would drop. Rainfall would get all chaotic. Some places would have no rain at all, others would have way too much. The soil would wash away, and yeah, the climate would just become completely unstable. It's pretty clear we absolutely need our forests.
But here's the good news. We can actually do something about this. So let's talk about bringing trees back. There are two really important ways that we can help. The first big idea is called conservation. It's a pretty simple concept, really. It just means the protection of animals, plants, and natural resources. So, step one is simply protecting the amazing forests that we already have. Now, besides protecting the forests we have, we can also plant new trees. And there are two main ways we do this. On one side, you have reforestation. Think of the re part, like redo. This is when we plant trees where there used to be a forest that got cut down. Then, on the other side, there's afforestation. This is a bit different. This is when we plant trees in an area that's never ever had a forest before. And both of these are so important. And this is happening all over the world, which is really awesome. In India, for example, there's this amazing festival called Van Mahotsav. And during this festival, they encourage everyone to get involved and to plant trees. It's a huge celebration of nature.
Okay, let's start to wrap this up. We're talking about protecting our future, and this is about why all of this really matters to you personally. And here's the really good news in all of this. Forests are what we call a renewable resource. And that's a huge deal. It means that unlike some things that are just gone forever once we use them, we can actually bring forests back. With a little bit of care and effort, we can always grow more. And that's really the main point here. When you think about it, protecting forests is protecting Earth itself. When we take care of our forests, we aren't just saving trees. We are taking care of our air, our water, our climates. We are taking care of our home. Have you ever really, truly looked at a forest? I mean, we see trees around us all the time. But today, we're going to dig into just how important forests are for, well, our entire planet. So let's just start with a little thought experiment. If you want, you can even close your eyes. I want you to picture a world with no trees at all.
What's the very first thing you feel? Probably the sun, right? It's just beating down on you. And there's no escape, no shade to be found. Anywhere.
Okay, now try to take a deep breath. The air, it feels kind of thick and stale. You know that clean, crisp feeling you get from fresh air? It's gone. Because the very things that make it are gone.
And finally, you look up at the sky. It just seems empty and blank. See, without forests helping to create clouds, there would be so much less rain. It's a pretty sad picture, isn't it?
All right, now that we have that image in our minds, let's get back to the basics. What even is a forest, really? Let's tune in and take a closer look. Well, at its core, the definition is actually pretty simple. A forest is just a large area of land that's covered with trees and bushes. We're not talking about a few trees in a park. We're talking about a huge community of them all growing together.
And there are two really important things to remember here. First, forests are renewable. That's a cool word that just means they can grow back if we give them the chance. And second, they are a home, a gigantic home for millions and millions of different plants and animals.
So let's zoom back out and look at that big picture again. You see, forests are always doing all this invisible work that helps the whole planet and every single one of us who lives on it.
So, how does all this invisible work, work? Okay, first up, clean air. Trees basically breathe in the carbon dioxide that we breathe out, and then they release the fresh oxygen that we all need to live. Second, they help make rain. Trees release this water vapor from their leaves, which goes up into the sky and helps form clouds. And third, they literally hold the ground together. Their roots are like a huge net under the ground, keeping the soil from washing away when it rains. So just take a moment and think about that. Knowing those three huge jobs that forests do for us, what do you think would happen if they were all gone?
Now let's go from that giant planet-wide view and zoom all the way down to the forest floor. Because a forest isn't just a bunch of quiet trees. It's actually a super busy, bustling home.
A forest provides what scientists call a habitat, which is really just a fancy word for a natural home for so many creatures. Birds, animals, insects, you name it. All of this variety of life is called biodiversity, and it's incredibly important for keeping our planet healthy and balanced.
And that gets us to this big idea of an ecosystem. All it really means is that everything is connected. The trees need the soil, the deer eat the plants, the birds eat the insects. They all depend on each other to survive. It's this very delicate balance, and if you take one piece away, it can affect everything else.
So we know forests help the planet, and we know they help animals. But what about us? Well, it turns out they give us tons of gifts that we use every single day, a lot of times without even thinking about it. Just think about your day so far, the wood that your house or your chair is made of, some medicines you might have taken, the fruit you had for a snack, even the rubber in the tires on a car, or the coffee and tea that adults drink. So much of this stuff gets its start in a forest. And it's not just things we can hold. Forests are also like giant natural air conditioners. See, trees release these tiny, tiny droplets of water from their leaves, and this process actually cools the air all around them. It's like a built-in cooling system for the planet. Pretty cool, huh? Okay, for this last part, we have to zoom out one more time to look at a really serious problem. Because even with all these amazing things we've just talked about, forests all over the world are disappearing. The official word for this problem is deforestation, and it means exactly what it sounds like, the large-scale destruction of forests, most often because of things that people do. It's really important to understand both sides of this. On one side, you have the cause. Why are trees being cut down? Well, to make space. Space for us to build roads and houses and farms to grow food. But on the other side, you have the effect. What happens next? When those forests are gone, the homes for all of those millions of life forms, they're gone too. And this leaves us with a really tough final question to think about. We know we need farms for our food and roads to get around. So, is cutting down trees always a bad thing? And why or why not? It's a complicated problem, for sure. And maybe the answer is all about finding a balance between what we humans need and what our planet needs to stay healthy.
You know, have you ever stopped to think about what connects, say, the light in your room, the car you drive, and even the phone in your hand? The answer isn't just about technology. It's actually geology. So today, we're going to dig in and uncover these hidden resources, the ones buried deep within the Earth, that literally power our entire world.
All right, to really get a handle on how important these things are, let's start with a few super simple things we all do every single day, probably without even thinking about it.
Okay, so you flick a switch. Bam! The room is flooded with light, right? But that energy, it doesn't just magically appear at the switch. Nope. Its journey started somewhere else entirely, usually deep, deep underground. Or, hey, think about this. You turn a key, and this massive 2-ton machine just roars to life, ready to go. Well, the power that makes that happen? It has an incredibly ancient origin. We're talking millions of years old.
And now, just look around you for a second. The very screen you're watching this on, the building you're sitting in. What gives it all its strength? What's holding it all together? The answer is, quite literally, all around us. And it's all been pulled from the Earth.
So the truth is, every single one of these modern marvels, light, cars, buildings, they all depend on resources we dig up out of the planet. And here's the kicker, the really crucial part. Unlike the air we breathe or the sunlight that hits us every day, there's a limited supply of this stuff.
Okay, so let's start with the planet's fundamental building blocks. We're talking about minerals. I mean, these are basically the raw materials that built our entire civilization.
So what exactly is a mineral, anyway? Well, to put it simply, it's a natural substance that we find in the ground, and to get our hands on it, we have to mine for it. You know, pretty much every single thing you can see right now that didn't grow out of the ground is either a mineral itself or was made from one.
And we use them for, well, for everything. I mean, think about the high-strength steel in our tools, or the lightweight aluminum that makes our cars more efficient, the concrete in our homes, and yeah, even the tiny, super important rare earth elements that make the circuits in your phone work. Minerals are the absolute foundation of our technology.
So we can kind of split them into two big groups. On one hand, you've got your metallic minerals. These are the ones we love for their strength and how well they conduct electricity. Things like iron, copper, and aluminum. But then you've got the non-metallic minerals. And these might not sound as exciting, but just think about it for a sec. Gypsum gives us drywall. Limestone is absolutely essential for cement. And salt, I mean, that's been a cornerstone of, well, everything from preserving food to global trade for thousands of years.
Let's just zero in on iron for a second. Have you ever wondered why iron, of all things, became the backbone of modern construction? Why it's in everything from massive skyscrapers to huge bridges? Well, it all boils down to this. It has an incredible strength-to-cost ratio, and it's just super durable. Okay, so if minerals are the building blocks, then you've got to have energy, right? Energy to shape them, move them, and power the entire world we've built with them. And that, well, that brings us to the planet's buried energy source, fossil fuels.
You know, a really cool way to think about fossil fuels is as stored sunshine from millions of years ago. Seriously, we're talking about energy sources like coal, petroleum, and natural gas, and they're all formed from the super concentrated remains of ancient plants and animals.
And how they're made is, well, it's like this epic slow-motion recipe. It starts with ancient life, plants and animals, dying, and then getting buried under layers and layers of sediment. Then, over millions of years, this insane amount of pressure and deep heat from the Earth literally cooks all that organic matter. It concentrates all that energy and transforms it into the fuels we use to run our world today.
And their impact? Oh man, it's almost impossible to overstate. Coal,
That generates a huge amount of our electricity. Petroleum gets refined into petrol and diesel, which powers pretty much all of our modern transportation. Natural gas, that heats our homes, cooks our food, and makes even more electricity. When you put them all together, they are the engine of global industry, period.
And this brings us to the most crucial point about both of these resources. It's this great imbalance that's at the very heart of how we use them.
I want this number to really sink in for a second. Millions of years. It takes nature millions of years to create these deposits of minerals and fossil fuels. I mean, to put that in perspective, our entire species, modern humans, we've only been around for a tiny, tiny fraction of that time.
And yet, we are burning through them. We're using them up at a rate that is just breathtakingly fast by comparison. It's kind of like the geological version of taking your entire life savings and just spending it all in one afternoon.
And this imbalance, that's exactly what we mean when we call something a non-renewable resource. It means that, for us, for all practical purposes, once we use it up, it's gone. We just can't make more of it on any kind of timescale that matters to human civilization.
So I'll just leave you with this thought to chew on. We have built our entire modern world on a foundation of materials that will run out, and we've powered it with a source of energy that will also run out. So, what do you think is going to happen when the engine that powers our world finally starts to sputter and run out of fuel?
Hello, and welcome. Today, we're going to talk about something that powers pretty much everything around you. We're going to look at the special treasures we get from the earth and why they won't last forever. I want you to just think about a few simple things you do every day, like flipping a switch and turning on a light. Or what about starting a car? Think about the energy it takes to get from one place to another. Or even easier, just look outside at a building, any building at all. You see, the light, the car, the building, all of them, they're connected. They exist because of minerals and fossil fuels that come from deep inside the earth. They really are the foundation of the world we live in today. So let's start with that first treasure. Let's talk about what minerals actually are and why we call them the building blocks of our world. So what is a mineral? Well, it's really simple. A mineral is a substance that's found in nature. It's not something people make in a lab or a factory. It comes from the earth, and we get it out by mining. And we can split them into two big groups. First, you have your metallic minerals, things like iron, copper, and aluminum. Then you have the non-metallic ones. This includes stuff like salt, the kind you put on your food, and limestone, which is used to make buildings. So what do we use them for? Gosh, almost everything. We use minerals to make our tools, to build our machines. They form the structures of our homes and schools, and they're even inside the electronics you're probably using at this very moment. Okay, now for the second treasure. Let's talk about fossil fuels. This is where we get a huge amount of our energy. And the story starts a very, very long time ago. The name kind of gives it away, right? A fossil fuel is, well, a fuel that comes from fossils. It's made from all the ancient plants and animals that died millions and millions of years ago. And it's a process that takes an incredible amount of time. It all started way back when. Ancient plants and animals died. Then, over millions of years, their remains got buried deeper and deeper under layers of rock and dirt. All of that pressure, combined with the heat from the earth, basically cooked those remains and slowly turned them into coal, oil, and natural gas. And today, we use these fuels to power just about everything. We burn coal in huge power plants to make electricity.
We turn petroleum into the petrol and diesel that run our cars and buses. And we use natural gas to cook our food and heat our homes. They are the engine that keeps our world running.
But there's a problem, a really big one. And that brings us to what we can call the non-renewable clock. It's the reason why these amazing resources won't be around forever.
So, just stop and think about that for a second. We use them for everything. What do you think would happen if one day they were all gone?
Here's a problem in a nutshell. It takes nature millions of years to make these fossil fuels, but it's only taken us a few hundred years to use up a huge amount of them. That balance is way off.
And this is exactly why we call them non-renewable. Think about it. They take millions of years to form. We are using them up so much faster than nature can make more. That means once we use them up, they're gone. We can't just make more.
Okay, so knowing that we have this big challenge, what can we do? Let's talk about the impact this is having, and more importantly, let's talk about the solutions.
Using all these resources has a big effect on our planet. When we burn fossil fuels, it releases a gas called carbon dioxide. That leads to air pollution, and it's making the whole planet warmer. And the mining we do to get these resources can also damage the land and the homes of plants and animals. But the good news is we have a path forward. There are other options. We can use renewable energy, like power from the sun and the wind, which never runs out. We can also practice conservation, which is just a fancy word for being careful and using less. And we can work towards something called sustainable development, which means we meet our needs today, but we do it in a way that doesn't hurt the earth for people in the future. And that really brings us to the most important part, tomorrow's energy. Because what happens next is really up to us. You've probably seen this in movies or read it in books, right? Stories about the future where people are struggling because they've run out of fuel to power their world. Well, that isn't just a made-up story. It's a real problem. And right now, today, countries all over the world are already working hard to find new, cleaner ways to get energy. You see, the small choices we all make every day are what will decide our future. It's not just a question for scientists or world leaders. It's a question for you, too. Your choices matter. So, what will you choose?